This video is to continue helping you with CR number 31 while I have to be out of the classroom this week. It says solve, write your answer in scientific notation. I think I'll solve this problem two ways. The first way is I'm going to just multiply it as it is in scientific notation, and the second way will be writing it in standard form, multiplying the values, and then putting it back into scientific notation. Okay, so let's take a look here. It says 9 times 10 to the 4th times the quantity 3 times 10 to the 12th. Well, we know when we're multiplying in scientific notation, you just multiply your first factors. 9 times 3 is 27 times 10 to the, well, when you have the same base and you're multiplying, you keep the base and you add the exponents. We know that from our multiplication rules. So 4 plus 12 is 16. So this is 27 times 10 to the 16th. This isn't in scientific notation yet, though, because our first factor has to be between 1 and 10. So right now, the decimal point is at the end of the number. We actually need to move it 1 to the left. And your teachers may have reminded you LA, like LA notebook, left add. Or they may have said you had a good friend Lars, left add, right subtract. So if we're moving our decimal point 1 to the left, we're going to add 1 here to our exponent, and it's 2.7 times 10 to the 17th. Now, if that's not comfortable for you, you could always rewrite each of the given values in standard form, then multiply them, put back in scientific notation. So now I'll talk about the second way to go about this problem. 9 times 10 to the 4th would be 9. 10 to the 4th says we have 1, 2, 3, 4 zeros. 3 times 10 to the 12th says we have a 3 with 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is kind of cray-cray, but you could do it this way. 9 times 3 is 27, and then how many zeros do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, just like we thought. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then to put that back in scientific notation, you do 2.7 times 10 to some value to figure out what value. First of all, you know it's a huge number, so it's going to be a positive value. You just say, how far over do I move that decimal point? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17 places over. Mrs. Pearson always says, when in doubt, write it out. So if you're not sure how to multiply leaving it in scientific notation, put it in standard form, multiply it together, and then go ahead and put it back in scientific notation. Hopefully one of those methods works for you. Let's talk about number 8. Find the measure of the angles. Lines L and M are parallel. Okay, well, if we know the lines are parallel, we're given this angle. We're given this angle. Those angles are actually alternate exterior angles. Alternate exterior angles are congruent when two lines are parallel. So that tells me this angle is exactly the same size as that angle. In mathematics, when two things are exactly the same amount, we say they are equal. So let's take our first angle, 6x plus 35, and set it equal to the other angle we're given, 8x plus 25. Now we're just going to simply solve for x. I'm going to move all my constants over to the right. I'm going to subtract 35 on both sides of my equal sign. Then I have 6x equals 8x. 25 minus 35 is a negative 10. I always choose to move all my constants to the right. You don't have to. Now I'm going to move all my variables, my x's, to the left. So I'm going to subtract 8x on each side. 6x minus 8x. 6x minus 8x is negative 2x. 8x minus 8x zeroes out. And on this side, I'm left with negative 10. To get x all by itself, I'm simply going to divide this side by -2 because it's -2 times x. We undo multiplication with division. I'm going to divide the left side by -2. I'm going to divide the right side by -2. So x equals negative times a negative is a positive. 10 divided by 2 is 5. So x would be 5 degrees, but they want the measure of the angles. So this angle right here is 6x plus 35. That would be 6 times in place of x. I'm going to substitute in a 5. 6 times 5 plus 35. 6 times 5 is 30 plus 35. That angle right there is 30 plus 35 is 65 degrees. Now I know this angle also has to be 65 degrees because those are alternate exterior angles. But you can always check to be sure. 8x plus 25, again, we found x to be 5. Substitute that right in. That would be 8 times 5 plus 25. 8 times 5 is 40 plus 25. 40 plus 25 is 65 degrees. Those two angles are both 65 degrees. All right, let's take a look at number 9. It says find the value of x. All righty. We're looking for that x value right there. If I look here, because this is all one line, I know the slope of that line will match. So the slope between this point and this point, however far up and to the right I go, has to match the slope between this point and this point. It also has to match the slope between our first point, if I go all the way up and then all the way to the right to that point. The slope has to match. It's all on the same line. So I'm just going to use my slope formula. M equals y2 minus y1 over x2 minus x1. And if I'm finding the slope between these 2 points, that would have to match the slope between these 2 points, between any 2 points on that line. So that's what I'm going to do. Lots of ways to go about this problem. I'm going to choose to use the slope formula. So I'm going to call this 0, 5, x1, y1. For my first equation, I'm going to call this x, 8, x2, y2. All right, so in my slope formula, y2 is 8. So I have 8 minus y1 is 5 over x2, oh, that's x, I don't know it, minus x1 is 0. 8 minus 5 is 3. X minus 0 is x. All right, so between those 2 points, I don't know x yet. I'm going to find it, but the slope would be 3 over x. Now what I'm going to do, I'm going to erase all this stuff. Now I'm going to call this first point x1, y1. And this point up here I could call x2, y2 and apply the formula again and know whatever I get there, it has to be the same as 3 over x. So I'm going to apply the same slope formula now with these 2 points. It shouldn't matter what 2 points I go between. If they all lie on the same line, the slope has to match. So now I'm going to call this y2. y2 would be 11 minus y1 is 5 over x2 is 8 minus x1 is 0. So now I have 11 minus 5 is 6 over 8 minus 0 is 8. All I did was between 2 different points, I used my slope formula twice. And now I'm going to be able to figure out x. So if I look here, 3 times what is 6? Well, 3 times 2 is 6. So something times 2 is 8. Oh, that x must be 4. 3/4 is the same as 6/8. 3/4 and 6/8 represents the exact same value. So x must be 4. Lots of ways to go about it, but I used our slope formula along that line. I hope that helps. Let's take a look at number 10. If triangle ABC with vertex points A, -4, 4, A is -4, 4, B is -1, 4, and C is -2, 1. If I take that triangle, I make sure I label it ABC. Again, I don't have a straight edge, you do, so hopefully yours looks a lot nicer than mine. Is translated 4 units to the right and 3 units down. Graph and label the image. Okay, 4 units to the right, 3 units down. So I start at A. I move 1, 2, 3, 4 units to the right, and 1, 2, 3 units down. That must be A prime. Go to B. 1, 2, 3, 4 units to the right, 1, 2, 3 units down. That must be B. C, if I go 1, 2, 3, 4 units to the right, and 1, 2, 3 units down, that must be C. And there we have it. Hopefully that looks pretty good. Ooh, kind of ugly, but that's B prime, C prime. So label and graph that image. There's your image. Mine's ugly, but there's your image. Let's just see, 1, 2, 3, still 1, 2, 3. The height is 1, 2, 3 high. Let's just be sure, 1, 2, 3 high. Yeah, it looks pretty good to me. Hopefully that helped with your CR this week. I will see you all on Thursday.